Alright, so let's work on this problem. We've got kind of a T-shaped structure. It looks like it's made out of concrete, but that's not that important. So we want to do the composite method. There's a couple different ways to do it. I think what I'm going to do is break it into two rectangles. So I call this, say, rectangle 1 and rectangle 2. And since we're trying to find the y value for the centroid, I want to find the centroidal values for each of the rectangles, again, from y. So remember, the way we do this is we create a table. First we'll have the area of each object. So I'll have section 1, section 2, and then I'll have its individual, not x, y value. And then, of course, I'll form that product of those two. And then, of course, in the end, we're going to sum all this stuff up. The numbers are going to be kind of big here. So the area of the first object, it's 120 by, what is that? 480, 600. So these numbers are going to get huge. 120 times 600, 72,000. And that's going to be millimeters squared. I didn't give myself enough room here. Let me rewrite it this way, since these numbers are going to get big. Sorry about the mess. So the distance from our reference point to the centroid of this, well, first of all, the centroid's halfway, so that's 60 millimeters plus 240, that'll be 300 millimeters. And then area 2 is 120 by 240. That's 28,800. And that will be millimeters squared. And the distance from our reference point to its centroid is half the distance, which is half of 240, which is 120. So now I form the product. So the first one, let's do the last one. 28,800 times 120 is a little big. 3,456,000. And that'll be millimeters cubed. And the first one is 21,600,000 millimeters cubed. So I want these sums. So the last one looks like it's 25,056,000. And then the sum of the areas, is that 100,800? So it looks like y bar is going to be this divided by that. So 25,056,000 millimeters cubed divided by 100,800 millimeters squared. Whatever that is. 248.6. Millimeters. That's a pretty simple application of that. It gives you the idea. So again, remember with the composite section, you're just going to take the information that you know about each of the simple sections and find the area, the distance to its centroid, find that product, sum those two, the difference is the value, the composite value. Any question about that? Yeah.
Yeah. The Y bar, sir? You said the A is the area. The Y bar is the distance from the distance to the center of that figure.
Little squiggly Y
Yes.
is the distance. We're measuring everything from the base. See, they wanted Y bar measured from the base. So it's the distance from that line up to the centroid of each of the composite sections. So we know the centroid of a rectangle is half the height. So I went half the height, which is 240, which is 120. Then I also know the centroid for section 1 was midway in its point. So midway of 120 is 60, but then I have to come the other 240 down to the reference point. You see that?
So on the first shape, they want you to come from X.
So this is the height that I'm worried about for the first one, and this is the height. I'm sorry, for the second one. This is for the first one. But they're all measured from this reference point because they indicated that's where they wanted the centroid located from the base. We'll do one more of these where the shapes are a little more complicated. We'll do that one next. So let me go ahead and
There was one on the homework that was 3D.